Okay, welcome everyone to our webinar about authentication. I'm Natalia. I'm from the Women in Technology Association. So a few words about our association. We are a community of women who work or want to work in IT or any other related fields. We are a community of women who want to share their knowledge, and we organize different types of workshops, meetups, or webinars. Our goal is to help others develop their skills of any types, and to show them how to be good and effective leaders. Okay, now over to you.
Hi all, I'm happy and pleased actually to welcome you all on behalf of Akamai Technologies, so the company that together with Gosia we are working for. And we are very happy to be here and share with you today a few tips and recommendations when it comes to securing your app. But before that, I would like to just tell you a few words who we are and what we do and why we call ourselves the experts when it comes to securing the apps. So our company was founded 23 years ago with right now over 8,000 employees globally. And in a nutshell, what we do, so our main area of expertise is actually content delivery network. So in a simple words, we make the internet faster thanks to our network, and the web security products. So basically, we are making sure that the internet is more secure, which I believe that we all can agree that is something that is getting more and more important nowadays. And our Krakow office actually launched in 2018, and we started with only 3 employees on board. And today we are the largest office in Europe with over 900 employees on board. And I'm proud to say that actually year after year we are awarded as a best place to work in Poland, which I hope speaks for yourselves. And actually our Krakow office continues to grow all the time. And we are always looking for new people to join us. So for all kind of roles, actually, starting with IT, tech support, security, sales, finance, HR, and so on, including interns for our paid internship program. So if you are interested, and you can find all of the links actually in the description of the event. And I don't want to keep you any longer. So let's start our event, and over to you, Gosia. Thank you.
Okay, so hello everyone. I am Gosia. I am an engineering manager in Akamai. Right now I am managing a team of software developers that work on authentication to Akamai Control Center. And Akamai Control Center is a platform for our customers to configure Akamai products. So because we actually handle almost a third of an internet traffic, I like to say about my team that we are developing authentication to the internet. So I have not always been a manager. I actually have more or less 15 years of experience in IT. Most of this was as a software developer on various stages, also as a full stack engineer. Okay, so I really wish I could see you all. So I hope you will be engaging a little bit through the chat. I will be able to see what you think. If you have any questions, you can ask them on the chat. I try to respond when I see a question. Okay, so let's talk about authentication. So authentication in general is a process of verifying if somebody who claims to be someone is really the person he declares he is. Pretty easy. So what is the most common authentication method? So how do you think? You can write on the chat. What do you think is the most commonly used authentication method? I'm pretty sure you've been using this a lot yourself. So you can use the chat or comments see to put your answers there. Okay, so I think the most common, well, I know that the most common authentication method is, of course, a username and password. So this is how usually users get authenticated. Yes, exactly. Thank you. Passwords. Thank you, Bartosz. And Vichura. So how this usually looks like? So there are a couple of ways how the authentication through the username and password is done. So the most the easiest one is a basic authentication. So I'm not sure if you ever even saw something like this. So basic authentication. Have you guys ever seen a screen like this? Like this kind of pop-up on your browser. This is like browser generated. So this is actually the browser generated window for your authentication. And what happens underneath when we go to this web page? We send a request. This is typically a GET request. We get a 401 response, which is like a most common way to say that user is not authenticated. We do response 401, which means unauthorized, and the server should add a header, authenticate basic and some kind of a realm, and the browser for you will display this window here. So what happens next? We type in a username and password, and next time when we click sign in, the browser will automatically take our username and password and send it to the server. The only encoded that we have here is base 64. So base 64 is not really encoding. We have guest speakers. I'm sorry for that. Please don't mind them. So base 64 is not really an actual encoding that can keep something secret. So base 64 is a symmetric encoding that just usually was actually designed only to make things shorter and exclude any kind of like special characters. So I know that there are some people that can read Morse code when they hear it, then TD. So with base 64, I'm pretty sure that there are people with a capability to read base 64 fluently. I have never met people like this, but I'm pretty sure there are. So what we are doing actually here, we are sending this username and password practically not encoded to the server. And your browser remembers this username and password, and each time you send a request, this is being sent to the server. So I can demonstrate how this looks. So let's open developer tools, and let's try again. So you can see here that a request has been sent with, and the response is 401. This was done automatically by the browser. So let's try to log in. I happen to know for a fact that the password is guest. And the request was renewed. And you can see that in the request, there is a header which shows base 64 encoded my username and password. And I can actually prove it to you. So let's search for a base 64 decoder. And this is how easy you can decode this password. So decode, and you can see user guest, password guest. So this is how the basic authentication is done. So is this secure? Not really. Why is it secure? Isn't this secure? So next time I do any request here to those protected endpoints, what will happen? This base 64 encoded authentication will be sent again and again and again. So if anyone was to spoof your traffic or steal any of the requests that you are making, they just get ahead of your username and password, and they can use it any moment, anywhere, like 2 days later, and you are unable to protect from that. So somewhat easier or safer is the digest authentication. So the digest authentication is very similar. You send a request, then the server sends the response with the information that that we are unauthenticated here. And they also send something like a nonce. Nonce is a unique ID or random ID that they send. And they also send a realm, something that is like human readable, which in this case was this. So the same scenario happens. The pop-up comes out, and what the browser will do, it will take your username, the realm that you set, the password, this nonce, and will do MD4 hash from it and send it to the server. So this is more secure because MD4 isn't an encoding that can be decoded in any way. This is like just shortening this content here, and this content cannot be recovered. So what server does, it does actually the same and contains this MD4. So in this case, it's more secure. Although I have to say I have almost never seen this happening or this kind of authentication being used anywhere. So the most common way to send the username and password is to create a form on a page and allow user to send put here username and password, and then send it back using the post. So maybe let's try to show you. Let's go to Peginic website and open the developer tools here, and let's try. And password. Oh, you can actually show it. And let's try to log in here. So you can see the network traffic, and there is a password being sent via post. This is not a valid account, so we got 401 once again. And here you can see this is a payload, so the data that is being sent. And you can see that there is some information here that were taken from my browser. And also username is set as identifier, and the access, like the password, is sent as an access pin. So if this was successful, I would get probably a 200 response or a redirect somewhere. And what happens normally, if the password is correct, the server generates some kind of a session and sends me back usually the session token or a session ID. And typically this is put by the application in a cookie. And I'm sending this cookie over and over again. And the session is verified if the session is still valid. So based on this token, I am verified if my session is valid. And what is more secure about this solution is that this token usually doesn't last forever. Even if somebody steals this token, it's usually valid for a couple of hours. So it can only be used for that long. And what is more, if I actually log out, on the server side, this session should be invalidated and this token should no longer be accepted. So it is actually very important when you log in somewhere. It is actually very important to use the logout and not just close the browser window. Because if you close the browser window, the cookie will be usually cleaned. But if somebody stole your token, this token can be used for as long as the session is valid. So what can actually happen wrong in this kind of authentication? So I already said that your token can be stolen or your password can be stolen from a traffic, and we'll address this again. But what else can go wrong when how your password can be actually hacked? It really depends on you and how you set your password. So somebody might guess your password. This doesn't happen very often. However, I had a friend on the university. His password was always his username, his girlfriend's first name, and the date of her birth. So if you knew who he was dating, you could actually get anywhere with his passwords. The upside of this was that he was changing his password roughly once a month. But if you kept up to date, you actually knew what to do. The second and more professional and more common approach is a brute force attack. So how the brute force attack works? An attacker goes to a page and tries to input the random passwords over and over again. And at some point, he will be able to guess your password. And when the login is successful, then it means that he knows your password, and he can use this password to do malicious stuff on your account. So this actually happened a couple of years ago with Amazon Cloud. Apple Cloud. So when people are taking photos on their iPhones and they have the cloud, the integration with cloud, the photos get automatically uploaded to cloud, which is great because your photos are backed up. But it's not so great if somebody would steal your Apple ID, because the photos are in the cloud, and anybody who can log in as you, stealing your password, can actually get your photos. And it's even worse if those photos are very private and you don't really think of the fact that your content is being stored on the cloud. So there was actually a brute force attack that happened on Apple Cloud. And a lot of the celebrities have been leaked very private photos, including, for instance, Scarlett Johansson, which was, those photos were very, very widely distributed later. So how did this happen? The users were actually, somebody knew Scarlett Johansson Apple ID, which was probably her email address, and they just tried and tried and tried with the passwords, and they finally got to the correct one. Okay, so you'd probably say that, I am not able to type those passwords, how long this will take. And of course, nobody types in the passwords. So let me maybe show you how this is usually done. So let's try to open a terminal here. And let's use it to do some small hacking. So there's a very, very easy tool called Curl. This is a tool that allows you to perform the same request that we do from the browser. You can do this in a text mode. So we already know that here, this application here is returning 401 when we send the password to this URL, so via post. So we do it via post. We can copy the format of the data here. So so let's copy this. So this is what happens. Let's copy the URL that we are doing, and let's do -i because this will show us the full response here. And I did this request and I get 400, which is bad request, which is something different that I got from here. So it means that there is still something missing from this request that I'm sending. So I am guessing content type because this is very, very common. So let's copy the content type from the request header. Okay, so this is content type because it's sent in application JSON. If it's 400, it means it couldn't really read it. So let's try to add this header, content type application JSON. And so what did we get? Still 400. No, we got 401. Okay, so we do have a 401 here. And we did a very easy text request here. So what we can do next, we can go ahead and change this password. Whoa, sorry. Change this password here to a different password, password 123. Try again. We are, of course, getting 401 again. So once we have this, it's very easy for us to just write a script using bash that would just take random passwords and try over and over and over again. And this is how brute force attack can be done in a very, very easy way. So how can you protect from this kind of attacks? So the first and very easy thing that you should do when you write your application, when the user types in the bad password and then again, after 3 or 5 attempts, couple of attempts, you can just log the account and don't allow to log in anymore and send an email that they have to verify, or you can just lock it for 30 minutes. This is enough. And in this case, if they would have to wait 30 minutes after every 5 tries, that's not doable to guess this password again. So that's one way to protect yourself, and you should definitely do this. Oh, thank you, Bartosz. This is a very, very helpful thing. So you would say that when I go to Apple Cloud and I try to log in and I do this after 3 or 5 accounts, I am logged out. So why didn't this happen for Scarlett? So the reason for it is that you have to know about all of your authentication ways. So Apple did this for the iCloud online web page, but what they forgot is that they allowed a service authentication using the same username and password, and here they forgot to implement it. So this was the hole that was exploited in this case, and because iCloud is very popular and contains very sensitive data, it had very negative effects of certain celebrities. So you have to. This is a very easy thing to implement. You just have to remember to do this everywhere. Second thing you should do when your users set up their passwords, you would have to check the password strength, because the easier this password is, the easier the attacker would be able to guess. Well, they don't start with those passwords. They start with a very, very simple password that they would have. Like, what's a typical password anyone would use? So I would say ABC123. And this is a weak password, and we shouldn't allow a user to be able to use password like this. Or if we allow it, we could make him to change it every 7 days or something. So the password strength is usually calculated based on some of the, this is like an example passwords, right? Strength. So there are some of the parameters, and you can actually set them up for your application. So you should definitely calculate this and have the requirements on the password for like minimum requirements for a password strength. A second thing that you can do is, of course, when this kind of attack, brute force attack happens, you don't actually put random letters and numbers, because this is not how people typically set their passwords. So what you do actually something called a dictionary attack. So you take an actual words and permutate them in a way that people would normally use. And there are certain heuristics on how you should check the passwords. And every time some passwords are being cracked, they usually are added up to a database, and hackers use them first because they know that this is a typical thing to do. So there is a very nice website, Have I Been Pwned, that would allow you to check if your email address has been pwned. It collects data from certain places, usually from the data leaks. And the nice thing here, there is a password. You can actually check if the password that somebody is trying to set has been pwned. So let's try ABC123. And of course, somebody has used this password, and this password has been cracked. Let's try Kasia1983, which is actually the girl that my friend married. So I hope he doesn't still use this password, because it has been pwned as well. And of course, I wouldn't type here my usual and normal password, because what the hell? You don't put your passwords in places that you don't know what they do with them. So I wouldn't put my regular password in here, but they actually have an API that you can use that protects you for this. So you can use an API where you actually put only like a first couple of letters, and they send you back from the database the information that they have about those passwords. So you will actually get a number of passwords that you can match with the password that your user used. And in this case, you can tell your user, okay, please don't use this password because it's too easy. It is going to be used in dictionary attacks. So the other thing that you should definitely do, if you should not allow user to use the same password over and over again, because at some point every password is cracked, and at some point every password that they will set will be compromised. So if they are changing it frequently, it's also more secure. And what is usually frustrating for the users but necessary, you shouldn't allow them to use like the same 2 or 3 passwords like in a loop. You should always force the user to have a new original password, so you you can compare it against like 10 passwords that this user used before. And of course, forcing password change is also a very, very important thing to do. Okay, so what else can go wrong? So I'm always talking about this example because this is how I was hacked. So, but almost every person I know has exactly the same pattern that I did. So almost every person I know has some type of a password that is actually using anywhere where the password is necessary, like in some stupid, you cannot see your face picture modified unless you actually create an account, which requires your email and some password. So if you use the same password in every website you create like a fake password, then at some moment you will create an account with a fake with this usual password of yours. That is a malicious website that it sounds very fun, and your friend posted it on Facebook, but actually apart from giving you this nice content that this website has, it will also store your password and then try to reuse it in certain services. So, of course, a bonus is always when you put your email there or use your email as an account ID, and extra bonus if you put your email and the password the regular password that you put in this website is actually the same as your email password, and so they can already access your email. And of course, on top of this, if you are actually using this email as a reset password email on other services, then you're actually setting up yourself for a huge like danger in here, and some cyber attacks will definitely happen. So just please remember not to do this. So how can you protect from this? So first thing that you can do, you can allow single sign-on with any of the popular websites like Google or Facebook. So don't we just love it? Just click login with Google, and this will work. And this actually may give your users the possibility not to create accounts with the passwords that can be broken, or the passwords that can be already somewhere found, but they will use SSO, and this will drastically, well, first of all, make their life much easier. And for you, it will make your website more secure because you don't really have to worry about the passwords at all. And of course, for you, you should never repeat the passwords, but of course you will do it. So I know people who have those one-time emails that they use for those one-time accounts. I know people that just put a random password and always reset it if they ever need to do this. This is much better. So there is something called a password manager. And this is a very, very secure way to manage your passwords. So there is one of those mostly used password managers is 1Password, but there is also much more of them. So you actually have an account of 1Password, and it installs in browsers and different types of machines, like a plugin, and you have one master password there. And every password you do, your password manager generates for you and stores it in this one secure way. If a bonus points you get if you have some additional device to authenticate for this 1Password. And in these cases, every password is different. There is a question: what is the best password manager? So I don't want to be like advertising anything, but I do have a friend who is a very secure freak, and he is using 1Password. So if this is something that that he's using, I would trust it. So for you as a developer, in order for the username and password to be actually recognized by the password manager, what you should always do, you should always use this special password type of input, and somewhere together with the username as well. So this will help the password managers to recognize that this is a password, and actually allow those password managers to use. So definitely the good idea is to test your application if it works with a common password manager, because it will increase the security of your app. So another way to steal your password is a keylogger. And as you can see on the left, this is like a very old photo, because this is actually a workstation, probably some internet cafe. And this is a device that is put in the like between the keyboard and the actual device here. And you can see on the right, it screens all that you are typing. So of course, right now we are mainly using mobile device. This doesn't happen that often, but most of the keyloggers that are installed right now with some malicious software are, of course, the software keyloggers. So based on this, attackers can actually record your keyboard and send this information to be analyzed, and it's pretty easy to see that you are starting your online banking and then put your password. So this is one clever way to protect you both from keyloggers and from the fact that the traffic is being like your password is stolen from the traffic. So one is, you have this small keyboard when you can actually do this with your mouse instead of your keyboard, which is pretty fun. I guess not a bad idea. And the second one is for especially banks like it. So they generate a form in a way that you never actually input the password like on its own. So you only type parts of your password, so the attacker will not have or will not get the password as a whole to reuse later, which is very cool, but this has a lot of downside. So if you actually want to make it random, how much does it cost you? So if it was really random, how would you actually have to store your password on the server side? So in your database, probably, in order to generate something like this. So let me first tell you what normally happens and what you should always do. So you should never store the passwords as user set them in your database or on the disk, actually anywhere. So you shouldn't be ever able to read the passwords from your backend. So what you usually do instead is that user types in the password, it gets to your backend application, and you never store it. But based on this password that you get, you hash it. You actually usually add an extra salt for hashing, and you store the hashed value. So the hashed value of the password, from this, you are unable to decode the password, and you are unable to get it, even if you have this hash or a key or a salt. This is only like a digest of the password that is there. And each time user types in logs in and sends you the password, you get this, take the password that he did, hash it in the same way, For instance, right now everyone I think uses bcrypt. So you hash it and compare the hashes. So even if somebody breaks in, or if you have an employee that can read your database, because this happens, somebody gets an access to your server, or somebody would get an access to a backup copy of your database, which people don't tend to protect as much as they do with the original data. So in this case, this attacker will not be able to read the passwords and will not be able to even try to have a password in a way that they can actually reuse it to log in. So if you try to use this pattern here, if it's really random, you cannot really use this type of hashing. So what I noticed with this is actually my bank. So what I noticed with my bank, there is like a limited number of those combinations. I'm pretty sure it's not goes into hundreds. So there's no so many permutations of my password, and I'm guessing that the hashes of each of them are stored separately, so that the attacker cannot read it on the backend. But this is actually a more limited number that it is. And now I will tell you about the most popular way to steal the passwords. And this is funny because this is a way that is actually being used for, ever since the passwords were creating. This is the way the passwords has been stolen, and still it's the most successful way of hacking in general. I'm talking about phishing. So the way phishing works is that you get an email that usually links you somewhere to a place that is very similar to your login page. And this email says that you should input your username and password there for any reason, resetting or something else. And what actually happens, this email did not came from your bank or from your university or from your PGNiG account. This email was crafted by a malicious party, and the page that you actually went to is not a page of your bank. So this is how attacker would steal your password. They would just set up a very similar page and make you put your email and password in there, or username and password. So why this is so easy? And I will show you this based on my email. Well, not actually mine. So this is a regular email account, and I have some emails here. So I have an email from LinkedIn. So as you can see, it came from security no reply LinkedIn.com. And this is how we in general verify the identity of somebody who sent us an email. We are actually looking at here. So maybe a lot of you know this, especially if you ever coded sending emails by yourself and set up this SMTP server. But let me show you, there is something like the original version of the email. And this is what is actually being sent when the email is sent to you. So here on the beginning, you have some headers. And what you usually look for is this part, the from, because this is what shows up. And most people treat this as like a validated source that actually somebody that actually this is the person who sent us the email. So it came out from this mailbox. And some people don't realize that this is actually something that when you send an email programmatically from an SMTP server, you actually get it, you actually type it in. There can be anything there. If your SMTP server doesn't have any restriction on this, then it can be literally anything. It can be your email address in there. Somebody can actually spoof your email address like this. And that's why it's so easy. Of course, most common SMTP servers have this. But this is not true if you are, it's very easy to set up your own email service, especially if you write some software and you just do it. So in order to actually, the thing that is actually verified in here, you can see a lot of things here that help verification. So you see that there is a signature usually that verifies whatever it is. And here you have a received part. And the received part actually gives you the address of the server that sent this. And this is something that you can more or less trust. And you can see that this email actually comes from LinkedIn.com. So seems legit. Let me maybe show you another example. So I joined the Rossmann Club. And the Rossmann Club sent me a message that they welcome me. And let's open the original type of the message. And of course, from is what we saw there on the email. So portal Rossmann PL. But when you see the SMTP server here, you can see that it has nothing to do with Rossmann. It comes from something called email labs netpl. And of course, is this email spoofed? No, it only means that Rossmann actually went to this email labs and paid them to host their emailing services. But you can actually see from this that even if this is a Rossmann PL stuff, it doesn't necessarily need to come from there. So that's why phishing is usually so successful. So protecting from phishing is not that easy when you're developing an application. So, and that's why it's been with us for so long. The best way for this, I would say, would be, well, apart from things that I will tell you later, like second factor authentication. So the best thing here would be something like education of your users. So, and this happens very often. Usually I get at least twice a week from my bank notification that somebody is doing a phishing attacks, and please do not provide any password and this kind of verification there. So there actually, the Cornell University has created a website where they have over 700 emails that were actually phishing. So you can see here the psychological methods that are done. So out of and today's February 25th, so they actually have even one from here. So let me see. So this is the one that was a few days ago, logging from a new device. So this is a very neat example. So this is something that is being like a very common pattern for us. Usually when somebody logs in from a new device and it's the first login like this, we send him an email or her to explain the most the information, and if they didn't, that it means that their account has been hacked. And of course, if you send an email with a content that the user doesn't recognize this data, so somewhere from Texas, somebody logged into my account, and you put a link here. If this is not you, change your password. I don't know why there is no link here, but I'm pretty sure that there was. It was just removed. So if you put a link here, this person may be actually upset or urgent enough to actually click the link and change the password there, using, of course, the old password. And this is a very, like, usually those email address, those phishing emails, they usually contain some kind of urgency for the user, so they don't have the time to think of it. So what else can happen to your password? So I told you that somebody may actually steal your password. And this is right now far easier than it used to be, when everything was workstation and stationary internet. Right now, we all use the Wi-Fi. And when we use the Wi-Fi, we usually do the like connect. Well, I have my router here. So, but of course, I'm pretty sure it's nothing new for a lot of you. But when my device goes to my sends packages, they don't really go like this. They go everywhere. So everyone can actually read my traffic. So here is an example that somebody did. So they were, this maybe doesn't look that spectacular, but this traffic here that somebody is reading is actually being like read from the Wi-Fi that around. So you can see the packages here, and this is not very readable when you just see it. But every request and response that was sent to you and back is here, and with the entire contents and the headers, etc. So also this request when you send your password or you send any other protected contents, this is encoded. Usually they are pretty easy tools to use to decode this information. So that's how the attacker can actually get this data from your Wi-Fi traffic. So this is like I will tell you in a moment how to protect from this, because this is not that extreme example. But even worse thing that may happen, if you go, for instance, into Starbucks and you connect to a Wi-Fi that is called Starbucks free Wi-Fi, you usually trust that the provider of this is actually the Starbucks cafe that you're there. But if this Starbucks never had a Wi-Fi, or regardless of that, this may actually come from a guy that is on the in the table next to you. There is really no reason for the Wi-Fi is really not verified. So you can actually, when you connect, especially to like open Wi-Fi anywhere, you get like somewhere in the middle between you and the website that you're trying to reach is this router that you connected to, and all your data goes through this router. And of course, this router can very easily read your traffic. But even more so, what can it do? It can actually modify the traffic that is happening. This is called man-in-the-middle attack. So any router, especially if you're using it somewhere free, can, for instance, switch your bank account, like your bank website, with something else, and present you this under your bank URL. And if you put your password to log in there, it can forward this password to your bank, but in between, it will also read it and have your data. Or if you are sending or downloading some protected information, this also can be can be stolen from you. So, of course, there is a pretty easy way to protect from this. So almost every person that uses the computer knows that they should always check if this is an HTTPS traffic and if this lock is green, because this means, and that's true, when we have an HTTPS traffic, the origin of this domain is actually verified. So you know that you are going to the domain that you actually typed in, and the connectivity is encrypted, so that this man in the middle cannot really read this. And in this situation, you go to the hacker news.com. Anybody can read the traffic that is somewhere in between. So this works pretty okay if you use the browser. But if you have a device like me with applications to Facebook, applications like Android applications for my bank, there you don't really see this part here. And all you can do is trust that the person who wrote this application, first of all, is actually using the HTTPS traffic, because there is no checking here, and he did not disable this check here for verification. And what is even more fun, that if you have your Android device, a lot of things do stuff in background, and you don't really have to go to your bank to verify something, and you don't really have to log into Facebook. But the data is actually sometimes being exchanged without you even trying. So you get into the public Wi-Fi that you shouldn't trust, and you are generating this traffic that you might actually find malicious. And you're not even presented with a window to verify this. So I would like to tell you, why this is safe. But before I do this, I have to explain you a little bit from cryptography. So there are basically two ways of encrypting and decrypting things. So first thing is asymmetric cryptography. So the way it works, if a cryptography is symmetric, it means we have a key that is being used to encrypt and decrypt the text. So I have some text, I have a key for it, I can use this key to encrypt it, send it somewhere, and if this person has the same key here, then this person can actually decrypt and see what I wrote. And of course, everyone who has this key can decrypt my message, as well as me. I can decrypt the message that I encrypted myself using the same key. So with this cryptography, you have to be very secure with the key that you are giving somebody to decrypt your message, because when you are sending this, the key may be stolen, or you cannot really trust this person. Maybe if you cannot really trust the other party that is decrypting the messages, then you will get this key can be stolen, and your messages may be decrypted. So this is how symmetric cryptography works. So the asymmetric cryptography is a little bit something on top of that. So there is actually a way to generate two keys. So there is a pair of a key. One is typically one of them is called a public key and a private key. And the way it works is that you can encode a text or something using one of those keys. So let's say a public key. And you cannot use the same key to decode it. So if you wrote something and encrypted it with your public key, you cannot read it because if you don't have a private key. So if you do it this way and send it to somebody and somebody has a private key, this person can read what you wrote and nobody else can actually read it. And this is also from the other way around. If you have a public key, you can send this public key out everywhere. You can print it out and put it on the billboard because this is public data. And if you encrypt stuff using your private key that you never showed to anyone and send it out, anybody who has your public key can decrypt this information and be sure that this is actually you who sent this, because of the fact that if the information was decrypted, it means that it was used with your public key. This can also be used for signatures. So sometimes you don't have to encrypt the entire message. You can encrypt something from this, like a digest or a hash from this. So that's how you can actually verify that the message comes from a proper source. And this kind of cryptography, of course, is far more secure. But unfortunately, this is expensive. This usually takes more computing power to use. So when I say that the traffic with HTTPS is encrypted, it's actually encrypted with a protocol called TLS. Let me show you with a little more details how it works. So the first thing that happens, you go into your browser and you type a URL and you send this request to the server. So first thing that happens is you don't send the actual request yet. You send something called hello, and the server responds with a certificate. And the certificate here, he sends you his certificate with some kind of also encrypted message. So what you get is a certificate. And this certificate is not only contains the public key of the server, but is also signed by something called a certificate authority. So somewhere there in the internet, in a secure place, there are those root certificates that were used to sign the certificate that you've been sent. So you verify the signature against this certificate, this authorized root certificate that you get from certificate authority. And if you can verify that the domain in the certificate is actually the same that you want here, this means that the server is actually the one that is that you're talking to, that you actually see in your browser. And this is being done automatically by your browser or by, if you do this, by your system. So you can actually check the certificates. I will show you my certificates. So you have like a keychain. This is usually a part of your system. You have a keychain and you have system roots in here. And here you see the roots that are like the trusted certificate authorities that your system trusts. And this is like the trust, the chain of trust starts with those certificates that you have here. So you can see that I have like VeriSign, I have something like SwissSign. So those are their couple of trusted certificate authorities that you can use. And I actually once took part in buying a certificate like this. So when you actually want to buy a certificate that confirms that you own a domain, I actually did it from Symantec. So Symantec actually verified if the request for the certificate that I made actually came from Akamai. But he didn't call me. He called actually somebody in Akamai that they have for the trusted, like somehow trusted for the communication. So this is like they actually verify if you own the domain that you want the certificate for. And when the certificate is verified, you do the asymmetric cryptography to exchange a symmetric key. So here you exchange a symmetric key, but you can only like you actually encrypt it with like some time frame and some additional information, and you use this public private key. So you know that this key came only from the server, and actually you also have like certain salt in there that nobody else can read this symmetric key. And only then your request is being actually encoded with this symmetric cryptography, and the normal HTTP process comes with this. So as you can see, the TLS is pretty hard to break and protects you from from two sides. First of all, you confirm who you are talking to, and nobody else can read the traffic that is happening there. So it's pretty secure. The question is it good enough? So in general, if those certificate authorities that are trusted are so good in verifying the identity of the server, then this is pretty good. But actually, even this was broken a couple of times. So first of all, you have to make sure that your browser or anyone verifies the certificate, so you don't ignore this green log. And every application has a possibility to disable this verification. You don't want to be doing this, and you don't want this application to be doing this. But there was also a very clever hack. This was in 2016. So you can see that each system comes from like predefined number of routes. And it was actually 2014. A batch of Lenovo laptops with a system installed had an additional certificate root installed in the system, which wasn't really a trusted CA. This was called Superfish, and it was used for some malicious work. And this was very hard to detect, because normally when you buy a new system, you don't really check if somebody, or you buy even a used computer with a system, you don't really check this thing. And it doesn't happen a lot. So this happened in 2014. They didn't discover it, I think, until 2016. Within this time, an owner of this root could actually create certificates that would sign domains that weren't really verified. So this is even this can be hacked in a clever way. Okay, so I said before that I will tell you how to protect from your password being stolen, like how to protect your users from their password being stolen. So regardless of what you do, especially if your users were like used for phishing, it may happen that the password was actually stolen. So what you can do, you can introduce something called a second factor authentication. So a second factor authentication is another layer of the authentication. So you go there and you place your username and password, and if the password is correct, you get a second question. So the second verification method may be, and in this case, something that you know. So for instance, you have a challenge question like, what is your mother's middle name? or maiden name or something like this. Favorite childhood friend, which is unfortunately not for current children, but for people that are older, they can actually name the favorite childhood friend. So in this case, this can be especially used for some sensitive actions like changing the password, so that you have to add like additional verification. So you can add on top of your username and password additional verification from 5 or 10 questions that somebody defined. Also, banks do this sometimes when they call us. They ask for some personal information about us. So this is one way to do. Second way to do a second factor authentication is use something that you have. And this is very popular. So first thing is various types of those number type of verification, which is called TOTP. So you install an application on your phone, and it generates a random number that is connected with the current time. And you have like a salt that is used for generate this. So on the backend, the application also knows what at this particular time what number should be verified, and it verifies. And you have to just type in this number as it appears. So it may be generated by this kind of a hardware token. It may be generated by your application. This is a new thing, very nice. It's called a YubiKey. It also generates some sort of numbers that are exchanged, but this one is actually even more fun. You just plug it in, and when the password prompt happens, you have to touch this small thing here, and it places the data like this numbers in your application as a second factor. So those are pretty nice things to verify. Of course, also the good way of verification is to verify by text message. It's less secure than our applications because, well, at least for Android, because Android actually has an API for applications to steal your text messages. So you can actually have malicious software that does it for you. For iPhones, it's more secure because on iPhone nobody can read your text message. But you can also have like an application. My bank has an additional authentication that just prompts me to approve the action that I'm doing. So this is a very, very nice thing, and a lot of services allows you to use it as an optional thing. So Google allows you to use it as optional. Facebook allows you to add it as optional, and this is something that adds a huge level of protection on your application. So if you have this option, I recommend you to actually use it. So the third thing you can use is something you are. So a typical thing is a fingerprint on your mobile device, or the face recognition. But also a very common thing is something called IP. I'm sorry, right now we don't use whitelisting. IP allow listing. So a list of if you know that you only want to put the allow users to access only from, for instance, from your office, then you can actually list the IPs that the users will get in the office, and only users from those IPs will be available. And the third thing that you can do, as I said before, you can actually use something called like single sign-on or delegated authentication. So here you can see that there are a lot of ways to log in, and you probably always have seen this screen in plenty of other applications that you are using. This is usually very easy, and most of those identity providers, this is how they're called, they would actually allow you to use this single sign-on for your application. So this is how single sign-on works. So you have one account there somewhere on Google, and a lot of so-called service providers may actually request from Google to verify your identity. And there are three. This is how right now, well, not right now, a couple of years ago, in United States, the popularity of the identity, like common identity providers there was. So most common is Facebook and Google, and if you have those two, you actually covered a lot of the traffic. So I definitely recommend if you try, use those two. So there are three most common ways to do. So first of all is an OpenID login. So OpenID works in each of those single sign-on ways. You have to actually go to Google, to Yahoo, to Facebook, or wherever, and register your application as a service provider. So what you do in OpenID, you are the relying party, and for instance, Facebook is an identity provider. So what happens here? You first register here as a relying party. The user comes first to you. They send a request, and what you do is you redirect them to the Facebook login page. And on the backend, you also go to Facebook and send this like one-time ID that they know, and you also use it in this redirect. So they can actually match the fact that the user who came to them, you actually as a relying party, you actually confirm the fact that they actually came from you. So when they log in, the identity provider sends you the information, yes, this was verified correctly, and the user goes back to you with his identity confirmed by the identity provider. So this is definitely used by Google, Yahoo. I think it should be also used by Facebook. I'm not sure. Another common single sign-on mechanism is SAML. In this case, you actually register within the identity provider, but you exchange something called metadata, which contain your public key. And you don't really, and this is the last time you speak to your identity provider. The moment that you send your metadata and your public key, the identity provider also gives you the public key from that they have. And the rest is only like from the client side. So the user comes to you, you redirect them to identity provider. The identity provider, so Facebook or Google, shows the login page. They log in, and what happens on the backend? Identity provider verifies their identity, and then creates something called a SAML response. There's a huge XML with user information in it, and with a signature created by their private certificate. And so they client side send it to you. So you don't really have to talk to the identity provider directly. So the user sends it to you, and based on the public certificate, you verify the identity. So that's how you actually verify. And this is still very popular, although not very new. It is definitely used by Google and LinkedIn. So the last one that is trending right now is OAuth. So OAuth has a lot of ways to generate the token. So usually it creates something. So usually when you register, like you're a resource and there's an authorization server. So when you register in your authorization server, you also exchange an information, and you get some sort of a secret or public key that is later used when the user goes to the application. The application usually redirects to a login page, and they request on the login page, after the verification, they request a token. This token can have different forms, but very often is encrypted by this private key. And the application sends this token to you, and knowing the public key of the authorization server, you can decrypt the token, and in the encrypted token, there's an information about the user. But also there is a way for so that you can actually connect there and verify the token itself. So there are many ways to use OAuth, and this is like the most common way. So the last thing I wanted to clear out from this is what is authentication and what is authorization. So you very often use something like authorized or authenticated. So there is actually a difference between those two. So authentication answers the question, who am I? And authorization answers the question, what can I do? So usually, as I showed to you, when you are not authenticated, you get 401 response that surprisingly is called unauthorized. And the 401 response tells you that you are not authenticated, and this usually triggers the authentication. And when you actually can't do something, so for instance, you are trying to access data that you don't have rights to, you go and you get a 403, and usually this ends the communication. You cannot recover from this. You should no access. Sorry. So sometimes, at some situations, you can actually try to trigger the authentication when somebody has, like, you can actually have an extra authorization and trigger the authentication based on this. So this is especially when you, for instance, reset the password. So usually you use the authorization to get a second level of authentication or re-authenticate the user before he can actually get and do the action here. And this is more or less all I have for you today. So let me just recap some of the important things. So first of all, try to use a second factor authentication wherever it's offered, and try to use it also in your application. Don't repeat passwords between different services. Use password managers. So like you can use 1Password, or on the comments, some people recommended something more. And allow single sign-on to the users. Okay, so do you guys have any questions? So I will be looking at the chat. So I hope this was some kind of informative to you, and you learn more, at least how to protect yourself, and better yet, protect your users. I can see the question, or it was asked before, the spectacular authentication attack you've ever heard of. So every application, like every big service was attacked. I was surprised to know. In LinkedIn, Allegro, everyone. The most like interesting one was, for me at least, was Ashley Madison. So if you don't know what Ashley Madison is, and I hope you don't, this is a dating site for married people. So this is a website that a married person can actually find another person to date. So of course, this is very, very sensitive data. And there was a huge leak of the data from there. Actually, the email accounts or the account names have been stolen, which was pretty easy to do. I think I know how they did it. And this was something called like a ransom attack. So they asked Ashley Madison to pay a ransom, and unless Ashley Madison pays it, they will publish this list. And Ashley Madison didn't pay it. And unfortunately, this very, very sensitive data have been leaked. Like they have been published everywhere. So it was a pretty big scandal. As you know, it's easy to check your boss's email and check if he has an account on Ashley Madison, which was pretty sensitive. But of course, a similar situation happened recently. So there was also like a ransom attack on CD Projekt Red, and they did publish parts of the CD Projekt source code, because this is what they managed to steal. Okay, do you guys have any other questions? Okay, so let me stop sharing. Okay, so thank you, everyone. I hope you enjoyed it. I really wish I could see you. Natalia, we can't hear you.
Can you hear me now? Okay, perfect. Thank you. So thank you everyone for joining our webinar. Remember, if you haven't been able to see the whole webinar, you can always see it again on YouTube, as this has been recorded. And remember to check our links in the description to learn, if you want to learn more about Akamai and women in technology.